Good afternoon, all. Good afternoon, all. This is Dr. Praveen, Associate Professor in SR University. Today I am going to explain Introduction to Programming. The topic is operators. Now, the main objective of this class is to learn operators concept in C language. So, in C language, we have mainly 8 types of operators out there. Here, we will discussing the main operators, 5 operators. Now, what is the operator first of all? An operator is a symbol, operates on a value or a variable. C has a wide range of operators to perform various operations. The first operator is the arithmetic operator. The second one is the increment and decrement operators and assignment operators, relational operators, logical operators, bitwise operators, and another one is the conditional operator and a special operator, right? And these are all main important operators in our C language. So now the first operator is the arithmetic operator. See, here we have a table. In this table, first operator one is that is called addition. Arithmetic operators, again, we have 5 arithmetic operators are there. An arithmetic operator performs mathematical operations such as addition, subtraction, multiplication, division, and numerical variables, numerical values. So now here, one is the arithmetic operator, first arithmetic operator is the addition arithmetic operator. The addition arithmetic operator that represent with the plus. I think everyone knows the addition. So we need to take the, actually, these operators can be categorized in 2 types. One is the binary operator, another one is the ternary operator. Okay, binary operators, these are all binary operators. Increment and decrement operator and assignment operator, these 2 are the unary operator. Binary operator, we need to take 2 operators, 2 operands. One is, like example, one is A, another one is B. So A, here A by B, we write like this, A by B, A plus B, A minus B, A star B, A division B, A mod B. So operators can be split into 2 types. One is binary, another one is the unary. Okay, the arithmetic operator is the binary operator. So now how can we write the program in a arithmetic operator? So now we want to go to the practical mode and we complete first all operators, then we write the program for all operators. So the next operator is the, here we have a small example for arithmetic operator. The first one is the arithmetic operator addition. So how many variables we have? 2 variables. One is A, another one is B. Now 9 is assigned to A, 4 is assigned to B. And we declare one more variable that is called C. So C equal to A plus B. Every line ending with semicolon already we, in previous class we discussed what is the structure of C language. So now the next one is the printf A plus B is the percentage D because it will return the integer value. So we have A is integer, B is also integer. That's why the output is also integer. So next to C equal to A plus B and you print the C value and A minus B is assigned to C. What is A value? Already 9 we declared, we assigned a value to A, 9. 4 is assigned to B. So 9 minus 4, 5 is assigned to C. Then we print the C value by using the printf statement. And next one is the multiplication. So A into B is assigned to C, then you print C value, as well as A division B and A mod B. So finally you print the values by using the arithmetic operators. So output here, see first output for the addition 13, for the subtraction that is 5, for the multiplication that is called 36, and A division B that is written 2, and because 2 point something, but here we take the integer. So to A mod B, that is also written 2. So finally we print the outputs. And next one is the next operator is the increment and decrement operator. It is important for the main placement point of view. It is important. What is increment? What is decrement? Okay, now this is the unary operator. First of all, in unary operator, we need only one variable, right? That is called A or B. So the unary operators always implemented on single variable. So single variable A is the variable. So A is the variable A plus plus. A plus plus. So A plus plus into the something. Okay, now here we take the variable is the A, is plus plus. Okay, next one variable is the A minus minus. See, this variable is the increment, this variable is the decrement variable. So now I want to write actually this can be categorized two types. One is the pre-increment, pre and post-increment. Another one is this is pre-decrement or post-decrement, right? Pre-increment, pre-decrement means, or post-increment, post-decrement means, pre means that is the prefix notation. Plus plus A is called the pre-increment. And post-increment means the operator is after operand. What is operand? Here A is the operand. Plus plus. A operand plus operand operator. So operand is A plus plus. So same thing is repeated here. Decrement operator. Pre-decrement. Pre-decrement means minus minus A, and post-decrement means A minus minus. So whenever we are use the pre and post, the difference between these two values, this is important here. Pre-increment, for example, I want to take small example. A. 5 is assigned to A. 5 is assigned to A. Now you take the plus plus here. Plus plus A means, this means first the value is incremented. That value is assigned to the variable. That value is assigned to it means A equal to plus. So we declare here. This is here. Some memory point is assigned to A. Okay, now the value is 5. So A equal to A plus 1. A plus plus means plus plus A or A plus plus. Both are, the meaning is A equal to A plus 1. Now the pre-increment, first value is increment by 1. Value, what is value? 5. 5 plus 1. What is 5 plus 1? 6. 6 is assigned to the variable. This is called the pre-increment or pre-decrement. The value will be, first value is decrement by 1, and that value is assigned to the variable. That is in the pre-decrement. I will explain. So now A value equal to 5, 5 plus 6, 6 is assigned to A, right? So value is 6. That is called the pre-increment. Now coming to post-increment. Post-increment means same A equal to post A equal to A plus A plus 1. In post-increment, first value is assigned to the variable. See, observe. First value is assigned to the variable. Next value after assignment, the value will be incremented by 1. You observe the difference between pre and post. Pre-increment, first value is incremented by 1. That value is assigned to the variable. So A value is first, initially we take the 5. 5 plus 1, 6 is assigned to the variable. This is in the pre-increment. Now post-increment, same thing is repeated. A equal to A plus 1. But now the first value is assigned to the variable. Here first increment the value. But here value is assigned to the variable. So what is A value? 5. 5 is assigned to the 5 after assignment. After assignment. A is A equal to A plus 1. A equal to A plus 1. So A equal to A plus 1. Now, the value is 5. Value is 5, but here value is 6. Assigning the value is 5. After the assigning, value will be incremented by 1. So, this is 6. Now, coming to the example, 10 is assigned to A, 100 is assigned to B. You observe here. First, we have take two variables. 10 is assigned to A, 100 is assigned to B, and we declare the one more variable like float. 10.5 is assigned to C, 100.5 is assigned to D. So plus A, percentage D, backslash N for new line, plus A. So what is A value? You write like this, A value 10. Now plus A. Plus A means A equal to A plus 1. Okay, it is pre-increment. Here where operator is the pre-operator. So A equal to A plus 1. A plus 1, 11. 11 is assigned to A. Now the A value is with display 11. Next, A plus plus. What is A value now? A value is 11. 11. So the same thing, A equal to A plus 1. So value is assigned to the variable because here we are using the post increment. Value is assigned to the A. So 11 is assigned to A. After assignment, this will be increment by 1. So it will be print the again 11, here 11, again 11. And B value minus minus. What is B value? B value is 100. Here we apply the pre-decrement. Pre-decrement means first value is decremented by 1. That value is assigned to the variable. So now I want to take the A equal to B equal to B minus 1. B value is 100. 100 minus 1, 99. 99 is assigned to the variable. So it will print the 99. Here also print the 99. Here 11.5. Here now this is the pre-decrement. Yeah, observe here pre-decrement 99.5. This is the output for the increment and decrement operators. It is very important for the technical rounds. So mainly focused on the increment and decrement operators. Next, see here we have some assignment questions are there. Now, what is the output for this example and as well as this example? Now, you know the x is x value that is called, what is x value? 10. And y value that is called 20. X into, that means 10 into y plus plus. Y plus plus means y value is assigned to the variable y. After assignment, it will be incremented by 1. So, y value is 20, 10 into 20, 200. Now, this is x, this is y. Y value is 20, x value is 10. So, there is no problem. Here, after assigning, value will be incremented by 1. So, first iteration, z value is 200 and a equal to x into y. What is x value? 10. Into what is y value? 21. So 210. So the output is 200, 200. This is the output for this example. And same way here we have one more example. X equal to 10, y equal to 20. So what is the output for this one? Anyone? So x value, you observe the x value. X value is again 10. So now x value 10 into plus y. You observe the plus y. Plus y means the value will, first value is increment by 1. That value is y equal to y plus 1. So 20 plus 1, 21 is assigned to the variable, so 21. So the value is 210. And a value equal to x into y, that is also 210. 210, comma 210. The output is 210 and 210. But this is for the increment operator. Next one is the assignment operator. I think everyone knows the assignment operator. Okay, assignment operator, it is a unary operator. Unary big means we need the one variable. So assign, now 10 is assigned to A. Now this is the right hand side, this is the left hand variable. Right hand side, any value is assigned to the left side variable. Now this is the shorthand assignment. These are all the shorthand assignments. Observe here. Shorthand assignments, so it means shorthand addition, shorthand subtraction, shorthand multiplication, shorthand division, and shorthand modulo division. So plus assign is nothing but a plus assign 10. We assume a plus assign 10 means this is nothing but a plus 10. Observe here. Without again we don't want to use the variable. So simply we have to write one shorthand assignment symbol, that is the plus sign. Okay, that means a plus a plus assign equal to 10. Now it is nothing but a equal to a plus 10. You observe the example. A plus a assign equal to b, it is nothing but a equal to a plus b. A minus assign equal to b, a equal to a minus b. Same way, we have another examples. This is the assignment operator. Next one, here we have some examples of there. C equal to C plus A. Now C aside C minus aside equal to A means C. Now C equal to C minus A. C equal to C into A. C equal to C by A. C equal to C mod A. Okay, we print the C values. That's it. And the very important operator is the relational operator. Observe here, a relation operator is a relation between two operands. Relation operator, check the relation between two operands. What is the two operands? First, we require the two operands for the program. One is called A, other one is called B. Now, what is the relation between these two variables? Is it equal, or is it greater than or less than, or is it not equal? Right? Is it greater than or equal to, or is it less than or equal to? What is the relation among these two variables? A equal to B, we assume. Right. If both are equal, then it will return true. True indicates 1. Right. Both are not equal, then it will return false. False indicates 0. I think everyone knows this concept. Now, plus plus equal to 5 equal to 3. Is it correct? No. Absolutely right. Wrong. So 5 equal to 3 is wrong. So it will return the 0. 0 means that is nothing but a false. Now A greater than B. What is A value? 5. What is B value? 3. 5 greater than 3. Yes, 100% it is correct. So it is evaluated to 1. 1 is now this condition is true. And A less than B. So 5 less than 3. So now the example. Now this condition is failed. 5 is greater than 3. Already we discussed. So this condition is failed. The evaluation is 0. So it means false. Okay, now A not equal to B. What is A value? 5. What is B value? 3. 5 not equal to 3. Yes, 100%. 5 not equal to 3 is wrong. Right. So it is evaluated false. And A greater than or equal to B and A less than or equal to B. I think you know greater than or equal. So for example, 5 greater than 5. Wrong. We assume 5 greater than 5 is wrong. 5 greater than or equal to 5. What do you mean? Either it is greater than or it is equal. So now greater than is wrong, equal is correct. So 5 equal to 5 is accepted always. Next one is less than or equal. It is also similar to previous concept. 5 less than or equal to 3. Now it is wrong because 5 is not less than or 5 is not equivalent to 3. So it will return false. This is the relational operator. Now how can we write the program for the relational operator? See, observe here. A value equal to 5, B value equal to 5, C value equal to C, 10 is assigned to C. So now we take the change the pen color. Okay, A equal to 5. A equal to 5, and now B that is also 5, and 10 is assigned to C. 10 is assigned to C. Now coming to first symbol, that is the equal to symbol, 5 equal to 5. Now this is absolutely right. So it will return 1. Now this printf statement will be written 1. Next, printf A equal to C. What is A value? 5. Y equal to 10. No, this is wrong. This is written false. That will return 0. And A greater than B. So you observe here percentage D, that is A value is assigned here. B value is assigned here. And is right. A greater than B is assigned here. So 5 greater than 5 is, what is 5 greater than 5? Is it true? Already we discussed. No, it is wrong. 0. This statement will be written 0. And A greater than C, the third, the next statement, percentage. 5 greater than 10 is, what is the output? Tell me. Output is 0. And next one is the A less than C. A less than C. Okay. A less than, you take the A 5 less than 10. Yes, 5 is less than 10 is than 1. So, and next one is not equal to B. Wrong. This is A value equal to 5, B value equal to 5. Both are equivalent. A not equal to C. Absolutely correct. 5 not equal to 10. It will return A greater than or equal to C. No. 5 greater than or equal to C is wrong. A less than or equal to B. No. A less than B. Yeah. Yeah. 5 less than or equal to 5. Less than is wrong. Equal to is correct. A less than or equal to C. Yes, that is also correct. Okay, now the relational operators is especially for the relation among two variables, right? So, two variables, more than two variables. Okay, if you want to take the more than two variables, then we should go for the logical operators. Okay, this is about the relational operator. And next one is the logical operator. You observe here. In C language, we have three logical operators. One is the logical and logical OR, and one more is the logical NOT. The three logical operators are there. What is the need of these three logical operators? Suppose now you want to write the one statement here, A greater than, how many operands we have? Two operands. One is A, another one is B. Sometimes we have to take more than two operands. One is A, another one A, B, and C. Now, how can we check the A is larger than B and C? How can you check B is larger than A and C? And C is larger than A and B. How can we check? We need one more operator that is called the logical operator. So logical operators are AND is the logical operator, OR is the logical operator, NOT is the logical. Logical AND we take the more than one condition. True only if all operators are true. All operators are true means now this condition is satisfied. Again, A greater than C. Now this condition is also satisfied. If both conditions are satisfied, then it will return 1. 1 means true. Now, if any one condition is failed, okay, I think everyone knows the conjunction. In conjunction, both are true, then return true. Okay, 1, 1, 1. 1, 0. 1, 0 means one is true, another one is false. 1, 0, it return 0. It means this is nothing but a conjunction. Conjunction means multiplication. Multiplication, B. Okay, 1 into 1. 1 into 1, return 1. 1 into 0, return 0. 0 into 1, return 0. And one more, 0 into 0, 0. So finally, both are true, then return true. Both are true, return true. Otherwise, remaining all situations, this will be return 0. So now coming to the point, an expression containing logical operator returns either 0 or depending upon whether the expression is as true or false. Logical operators are common in decision making. Logical and here this is the logical. Logical and true only all operators are. Now C 5 is assigned to C, 2 is assigned to D. C equal to 5, yes. What is C value? 5. 5 equal to 5, yes. Condition is satisfied. t greater than 5, 2 greater than 5, condition is fail. So 1 into 0, it will return 0. 1 into 0, already in table we discussed 1 into 0 return 0. And logical or if any one is true, then return true. This is a mathematically, we have one thing is there that is called the disjunction. Right? If any one is true, now 1 plus 0, 1 plus 1, true, then return true. 1 plus 0, return true. 0 plus 1, return true. 0 plus 0, then return false. So that is called the logical OR. Now C equal to 5, D equal to 2. Now here, logical and this will be written 0. Logical OR, if any one condition is true, then return. So C equal to 5, this condition is satisfied. And D greater than 5, this condition is same. Okay, 1, it will return 1, it will return 0. 1 plus 0, so 1. So the expression evaluates 1. And logical or not, logical not means if you are take a true statement that will return false. So C equal to 5. What is C? C equal to 5. That expression C equal to not C equal to 5. C equal to 5, it will return 1. Not 1. Not 1 means not 1. We have one other state, 1 is 0. So it will return 0. So these are the logical operators. In C language, we have three logical operators. Logical are, and one more is the logical. This is about the logical. And here we have small example is also available. Now, in the same values for ABC, and here result A equal to B. What is the A value and what is the B value? Both are true. And C greater than B, yes, condition is absolutely correct because 10 greater than 5. So result it will be written true. And result A equal to B. Okay, true. C less than B. Yeah, C less than B. What is C value? 10 less than 5. So no, this condition is failed. So it will return 1 into 0, return 0. This result is 0. And A equal to B is correct. And C less than B, it is again wrong. So, but here we apply the logical or any one is true, then return true. So this will be returned true. A not equal to B. This condition is failed. C less than B. This condition is also false. Both conditions are false. 0, 0, then result is 0. A not equal to B. Okay, 5 not equal to 5. 5 not equal to 5. No, 5 equal to 5. So not equal. So the output will be written reverse. And A equal to B, that is true. So not true. This will be written false. Now what is about this? Tell me. A not equal to B. Yes, condition is satisfied or not? No, this condition written 0, not 0. This will be written 1. This is about the logical operators. So that are very important operators. That is called the bitwise operators. Now, bitwise operators, again, we have 6 bitwise operators are available in our C language. Bitwise and now the main purpose to use the bitwise operators is if these are converted bit level, which makes processing is faster and saves the power. That's why sometimes in advanced programming we use the bitwise operators. So total we have 6 bitwise operators are there. And or exclusive or that is the negative arithmetic complement, left shift and right shift. So these are important. After here, we take some example. And first operator is the AND operator. So what is AND operator? We take values. We take the, I think everyone knows the how to convert decimal to binary. So now here we have two integers are there, 1 and 25. Now we have to take the binary value of 12. We have to take the binary value of 25. 12 binary value, you observe here, friends. Now 12 we convert from decimal to binary. Write here like this: 12 to the base 10, question mark to the base 2. So 2, 2, 6 and 12 return 0. And 2, 3 are 6 return 0. 2 1 ja 2, right? Return 1. So we have to write the most significant bit to least significant bit. 1 1 0 0. This is the binary code for 12. So how we'll get the 12? This is multiply with the 0, 2 power 0, multiply with 2 power 1, multiply with 2 power 2, multiply with 2 power 3. 8 plus 4, the value is 12. That is the binary value of 12. Same way, similarly, 25 binary value is 11001. So now the operator is bitwise. So the value you observe here, binary levels 0 into 1. What is the value? Operator is 0. Operator is AND operator. 0 into 1, return 0. 0 into 0, return 0. 1 into 0, 0. It 1 into 0, nothing but in conjunction, you observe here, 1, 1, 1. 1, 0, 0. 0, 1, 0. 0, 0, 0. So now the value of A, value of 1, value of 25. That is the binary value. 0, 1. What is 0, 1? 0. Bit level. 0. 0, 0. What is the bit level? 0. 1, 0. What is the bit level? 0. 1, 1. What is the level? 1. Remaining all are 0. So this is the output. So what is the decimal value of this binary value? So 8 is the decimal value. So this is about the bitwise AND. So you will remember one point, bitwise operators. First, the decimal value will be converted to binary value. We work on only binary values. When you are work on binary values, automatically you save power and you increase the computational speed. This is the bitwise. And coming to program, just we write one statement, A into B, then it will be written 8. That's it. Already we discussed. And bitwise R. Bitwise R is nothing but a plus. Okay. You know, 1, 1, 1. It means 1, 1. On, on. On, off, on. 0, 1 also. 0, 0, 0. We follow this table. Right? Okay, now coming to 1225, same values we have. 0 plus 1. What is the 0 plus 1? 0 plus 1, the value is 1. 0 plus 0, the value is 0. 1 plus 0, the value is 1. 1 plus 1, okay, 1. And 0 plus 1, 1. So 1, 1, 1, 0, 1. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 16 plus 8 plus 4 plus 1. So the value is 20. Value is 20. For the bitwise R in any one is true, then return true. And bitwise exclusive R. Here we have a small example for program ARB. This will be written 29. Already we discussed it. And bitwise exclusive R. Now here we observe the one condition 1 1 0 0 0. 1 0 written 1, 0 1 written 1. 1 0 written 1. 0 1 return 1. Remaining two situations, the value will be written 0. So the values are same values we have. 0 1, that will return 1, and 0 0 return 0, 1 0 return 1, 1 1. You observe here 1 1, what is the value? 0, and 0 1 value 1. So the final value of 1225 exclusive or that is 1221. Same program is there. You can have to take the caret symbol, write the caret symbol, right? That is called A, B, right? A, B. So A value is 12, B value 25. This will be written 21. This is the bitwise exclusive. The bitwise complement, that is the negation. Bitwise negation is nothing but n is, for example, n is 2, that will return 1. N is 2, it means, for example, now 1 0 0 0 is 1 0 0. Now negation of 1 0 0 1 0 0. So 0 return 1, 0 return 1, 0 return 1 return 0. That's it. Okay, now you have to take the negation of the two returns. Negation of 1. For example, negation of 12. 1, 1, 0, 1 is the 12. Negation of 1, 1 will be returned. 1 is first last bit. 0, 1, 0, 0. This will be written. That's it. Bitwise complement operator. That is the negation operator. And the very important is the right shift and the left shift. So right shift operator, that value is always increment by 1. Left shift operator, decrement by 1. Left shift operator, the value will be decremented. Right shift operator shift all bits towards right by certain number of specified bits. It is denoted by greater than. So the formula I want to share one formula, that is z equal to x greater than y. Z equal to x greater than. Okay, x greater than y indicates x equal to x by, right, 2 power y, 2 power y, x by 2 power y. That is called, y is the number of steps to move from right or left to right. That is the right shift operator. 2 power x, 2 power y. So sometimes we have to use the n by 2 power s. Then by 2 power s, n is the integer value, you denote integer value. S is the number of shifts, 2 power s. This is the important for the technical grounds. So directly we have written the value right shift. So now we take some actually computer architecture. We have a 16-bit architecture, 32-bit architecture, and a 64-bit architecture. Okay, now I want to take the 16-bit architecture. 16-bit architecture, before this, we take one example. Yes, n value equal to 8. N value equal to 8. So how can I write the, how can you take the bits? So 16 bits, 0, 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 15. Okay. 2 power n minus 1. So now what is the binary value of 8? 1. 1, 0, 0, 0. That's why I'm taking like this. This is the 16-bit architecture. Now, s equal to 2. It means you write like 8 greater than 2. 8 greater than 2. So now I want to shift to two steps. That is the bits towards the right by certain number of steps. How many steps we have? 2 steps are there because 8 greater than 2. Right shift to. So 1 is moved to right side, one step, and another step. So 1 is here and 0 is same. Remaining these are all zeros. All are zeros. So what is the value? 0, 1, 0. The binary value is 2. Now the same values are applied in the formula. N value is 8, 2 power 2. N value is 8, 2 power 2. 8 by 4, that out is 2. This is what we do. Right shift operator. Okay, now right shift operator will always, the value will be decremented. Now coming to right shift. After right shift, you go for the left shift operator. This is the quite opposite of the right shift operator. Now left shift operator shifts all bits towards left by a certain number of specified bits. The bit position that have been vacated by the left shift operator are filled with 0. The symbol is less than. So how can I write n less than 2? Previously we have n greater than 2. Now we have n less than 2. So n value is same way, n equal to 8, less than. Now again we take this same 16-bit architecture. Before that, We take formula that is called n by, n into 2 power s. N into 2 power s. The output is n value. What is n value? 8. 8 into 2 power. Number of shifts are 2. So this is left shift. Yeah, 8 into 2 power 2. So 8 value is moved to left side. So automatically the value will be incremented. 2 power 2, 4. So total the value will be root of 32. Okay, that is called the left shift. Now I want to take the example. See friends, 0, 0, 0, 0, 0, 5 zeros, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. See, left shift. Left shift means we move to left side. One shift and another shift. So remaining, when we are shift, the bits, the positions that have been vacated by the left shift operator are filled by 0. So this is 1, this is 0, the filled by 0, 0, 0, 0. Remaining all are zeros. Now 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. 2 power 5 equal to 32. What is the outcome here? N by 2 power n into 2 power s. N value is 8. S value equal to 2. So that output is n into 2 power s. So 2 power 2 for n into 4, 32. This is about the left shift operator. And next one is the now here we have an example. See this example. Say already we discussed this example. I will show the program also. I will take one program and with all the examples. And this is about the operator concept in our C language. Now I want to go to the next practical subject for this one. I want to stop here and stop this and share the. I think it is visible, everyone. So now we observe the Deus is cluster. I want to take one simple program here. But to write the program, all of you look here. Hash include first in C language, we have to write always comment section for the program. Write a C program to implement operators. Now, first line in C language is the hash include. Everyone knows HTTP. Now, I want to explain here hash is preprocessor. The preprocessor responsibility is to include standard input output header files. What are the functions in the input output header files? That is the printf and scanner. We have to take the printf and scanner from the header files for the hash file, that is the preprocessor. Now main, which execution is transferred from the main method. So that's why we take the main method and opcode statements, that is begin and end. And we declare the variables into A comma B comma C. Okay. Better I want to explain only bitwise operators because already I think everyone knows the logical operator, conditional operator. One more is that is called the relational operator. And I will explain conditional operator also after this concept. Into A comma B comma C. Now we write the bitwise operators. Here we implement the bitwise operators because everyone knows remaining operators. Bitwise operators. Printf enter two variables A and B expression, that is for the new line, every line ending with a semicolon. Semicolon now. And now C equal to, yeah, before this, read the variables can percentage D, again take the percentage D. The percentage D for the integer values. So here we declare, we read the two integer variables. One is called A, another one is called B, ending with semicolon. A and B variables. So now you after reading, now C equal to A greater than B. Yes. Right, printf, you write the printf A greater than, that is called percentage D greater than percentage D equal to percentage D backslash n comma A comma B comma A comma B comma A. Now close the comma statement and we compile and execute this program. But before compilation, we save the program. That is the program name is Bitwise operator in C language. Save as C. Yeah, now zero errors, zero. Okay, now I want to save the, yeah, I think it is usable. And A and B values, we read A value equal to 8, B value equal to A value equal to 8, B value equal to 2, because last example we discussed about right shift as well left shift 8 and 2. So the output is, we observe here. Here we have the output of this. Okay, now we close the statement here, close this one, and go to the program. Yeah, now go to the dev C++. Okay, now zero errors, zero warnings. So now again we want to take the C equal to A is there less than B semicolon. I want to copy this. Don't want to waste our time. Here copied. Just we change the operator less than. Now again we compile the value, compile and execute the program. Zero errors, zero warnings. Now sharing, go to the sharing here. See A and B value, same values I want to enter here. 8 and 2. 8 and 2. The output is 32. All of you look here. Now the output is 32. Left shift, the value is incremented. Right shift, the value will be decremented. This is the left shift and right shift. And what would you see the plus? Now I want to write directly here greater than and less than like that. Printf already these two are over and go to the bitwise and A and B equal to percentage. Sorry, right like this. Percentage D and percentage D equal to percentage D comma A comma B comma A and B. And we want to copy this statement. Statement. Now I want to change the operator. Instead of and, we should go for the R. This is the R operator. Here is the R operator. Yeah, here R operator. And we take the exclusive R operator. Then we go for the exclusive of the R operator. Exclusive R. Nice. I will go to the statement here. And the percentage D before use negation, where is negation? System negation, and the take negation, no need of these variables, negation, A, and here percentage E equal to percentage. Yeah, then we compile and execute this program. And now in this program, I implemented bitwise operators, which is right shift and left shift. And one more is the bitwise and bitwise or bitwise exclusive or bitwise negation. And compile and execute this program. Now you all of you look here, 0 errors, 0 warnings. Here, yeah, A and B values. A value is 8, B value is 8, and better you take the 2, that will be A. See, 8 greater than. Now already we discussed this example, 8 greater than 2. That will be written 8 greater than is written 0. Why 0? Anyone knows? Why 0? Already you know this rule. Right? Now why it will be written 0? So into the binary value is 1 triple 0. 8 binary value is 1 triple 0. 2 binary values 0 1 0. So finally all are the conjunction, both are true, then return. So 1 0 0 0 0 0 1 0. Look, always these are all multiplied. 0 0 return 0, 0 1 return 0, 0 0 again return 0, 1 0 return 0. So finally it will be written 4. And 8 or 2, 8 or 2, that is also that is written 1. 1 means 1 0. Well, now 1 triple 0 0 0 1 0. 0 0 1 0, 0 0 return 0, 0 1 return 1, and 0 0 return 0, 1 0 return 0, 0 1, right? So this will be written 10, 1 0 1 0, 1 0 1 0. So 1 0 1 0 is the binary value for 10, so it will return 10. And 8 exclusive are that is out 10. And finally, negation V value. Negation V value, that is the minus 9. This is about the bitwise and returns. Okay. And actually we did not complete one concept here. That is the operators. Now we have one more operator is there, that is called the conditional operator. Now conditional operator, all of you look here. Operator. So now we write like this: condition, question mark, expression 1, colon, expression 2. If this condition is satisfied, expression 1 will be evaluated. If this is for the true. If condition is failed, then expression 2 is written. It means conditional operator is actually, we have a conditional statements in our C language. That is the if else, later yesterday. In previous class, in some class, we completed this concept. So conditional, without conditional statements, we go for the conditional operator. So conditional operator, we write like this: A greater than question mark A colon B. Suppose 5 greater than 2 question mark 5 colon 2. See, the 5 greater than 2 is condition is satisfied. Condition is satisfied. Okay, because now always 5 is greater than 2. So the condition is satisfied. The first expression is evaluated. That is called in expression 1, We write like this: printf, simple printf A, colon, printf B. We write. It means it will print the A value. Suppose this condition, suppose now you take the 5 greater than 12. B value is 12, 5 greater than 12. The condition is failed. So you print the B value is the upper. That is called B is greater than. Okay, the conditional operator main objective is we have to reduce the number of lines and we have to improve the performance of the state. That's why we go for the conditional. This is about the conditional operators. Okay, and one more operator is the special operator. Special operator, that is the comma is the special operator, and ampersand is also special. So total in our C language we have 8 types of operators are there. So in this class we complete the 8 types of operators with suitable examples as well as practical session. Right? Once again you go for the previous slides. Now, see, these are the, okay, before this. Yeah. Now operators can be categorized. OP can be categorized 2 types: binary operator, unary operator. Unary operators are, one is increment, increment and decrement operator, right? Increment and decrement operator and assignment. Binary operator, remaining six variable, 6 is the binary operators. That is, arithmetic operator is the binary operator, assignment operator is the, relational operator is the binary, logical operator, conditional operator, special operator, bitwise operator, is all are the binary operators. So now we completed operators concept with examples. If you have any doubts, you ping me and you send a mail to the p.praveen@sru.edu.in. Myself, Dr. Praveen, Associate Professor in CS and AI, Department of Computer Science and Artificial Intelligence in SR University. Okay, next I will share another concept in C language, right? And conditional statements, control statement. I will give the every concept video lecture as well as so executed programs also I will share. Everything I will share to you, and all of you please like and subscribe this video. Thank you. Thank you, Varana.